Hi, welcome back. So last time we have seen the uniform distribution, which the last example we have seen is to find the probability. The way to do that is basically find the area under our density curve, right, inside a certain x interval, and find the area under the curve, which the curve is called the density function, which in together that mass, right, the piece we find is the mass under the density curve. That is called simply the probability between as our interval. Then for our normal distribution, which we can see the curve is a little harder, right? So that certain of limits for the normal distribution, one thing is, well, we have the curve with the criteria with the parameter, in other words, the mean and the variance. We have the shape of the bear curve. First thing is, well, from negative infinity to infinity, even though for some set x interval, right, the area under the curve, which will be very hard to find. Since we know for the continuous probability distribution, the area under the curve is its probability, right? So inside total will be 1, that's for certain. But for such interval and for that curvely density function, it is very hard actually. Not only not easy, but very hard to calculate the actual area. Also, there are so many normal distribution, which means for different mean and standard deviation, that's different type of normal distribution, which means our density function will be totally different, right? So many distribution have different mean and standard deviation. That what makes the shape of the curve looking totally different, even though area is not hard to find, but the mean and standard deviation are different, then we have too many things to worry about. Right, so that is one way to solve these two problems. We have a thing called standard normal distribution. The standard normal distribution, which is basically a normal distribution, but it has mean equal to 0 and the standard deviation equals to 1. Right, such gives the random variable as the standard normal distribution is the mean of 0 and standard deviation of 1, or variance of course is also 1. That it has the probability density function, is e to the minus z squared over 2 over radical of 2 pi. And that is the function of z, which is the same z we have seen before. Right? In other words, the z score we have seen. Right, which the z score for any random variable of x, right, has different mean and different variance. But what the z score do, as we mentioned before, was get rid of the effect of the mean, which the x minus mean will be centered at 0, and get rid of the effect of the standard deviation, which when we divide by the standard deviation, that will make the standard deviation of z score to be 1. Right, so which will be standardized. The random variable x become the z score, which the z is distributed as standard normal distribution. So what it does, right, this PDF is still hard to calculate its area, even though maybe you go to calculus 2, you can find out a way to do that. It's involving the some other things, like certain things like parametric function and the other knowledge we need, right? So that thing is not that much worry about. What we have here is the table A2. Right, so the area and the standard normal distribution can be calculated or actually can be found. And table A2, which table A2 is the z-score table, as you can find on Blackboard. I posted already. So that is what it is. Right, so whichever x provided, we can find the z-score, and use the z-score we can find the probability by the table A2. The only thing is we can see the table A2 provides the area under the curve to the left, and also the row and the column. A row and column here shows different things, so we need to know how to read the table. So when you have the table, right, we can see it has two sides, negative z-score side and positive z-score side, depending on which z-score you get. And it say, well, it is the standard normal distribution, have the cumulative area from the left. So that is what the table is asking for. Oh, we still have the z-score, is the standardized score, excluding the effect of mean and standard deviation for the usual normal distribution. It gets the standard normal distribution, z-score. And what we have, z-score, is from the table we can see now. Right? I always ask you to round the z-score into 2 digits, and the following nicely, right, for the rounding rule. If you do that, not that correct, which means 5 or more rounds up less than 4, 4 or less you round down, simply cancel the following digits. But if you're not following that much carefully, you can see even 1 digit will affect your answer, maybe greatly, maybe not that greatly, but will lead to the wrong answer. So 2 digits decimal, and the rule will be very strict, right? So try to keep that and make it correct. Right, 2 digits of decimal places, so it's what we need to keep for the z-score. Since we have the limitation of the table that only provides 2 digits of the z-score. And the table value is the A. We're looking for the table provides us the A. The probability of z-score less than A is phi of A, which phi of A is the table value. So when we calculate the z-score, we'll find the A. How the sign is, it's depending on the wording of the questions. But the table value we get is phi of A, which is the area to the left. So how we find the probability to the right of A will be 1 minus. And how we find the in between. Which basically is the difference of two values. So 3 cases. The phi of A is the cutting value for the z-score. To the left of the value, that's the probability. And the second, to be greater than the A, the middle is always 0 for the standard normal distribution. To be greater than the A, that is to the right of it, and in between it be that's shaded in the middle. Whichever the B and A is, or whichever they are, we just go to the table to look for our B and for our A. That is how we find the area in the middle. So that is the first case. These two curves are for the second case, and this one is for the last case we have. Right, such A value are the z-scores, could be negative, could be positive. Right, and you can find the z-score table or table A2 from the book, which is providing both positive and negative side. Right, so that is what it is. If you're looking for the less than, you go to the table, find the value, that's it. If you go looking for greater than, you go to the table, but after you find the value, you take 1 minus, which is the complement of the left side. And if you're finding two z-scores in between them, to find the probability, you just find the difference of two values. So how we actually reach the table, right? Let's see the example and we'll see. But the first idea is to find the probability less. We just go to the table to get the value out. If finding more than A, that we go to the table to find its complement, and in between we just find the value in between, which is the larger minus the smaller, in other words. Then we will see how to read the table by looking at the example. So this question, what it say? Right, scientific thermometer should show 0 degrees Celsius at freezing temperature when water freezes. Now, of course, at 1 atmosphere pressure, because of the pressure may be different, and some other cases, or even the construction itself can make the thermometer not work that well, but acceptable is the error. Right? The error is always acceptable. And here I say some shows positive value, some shows negative value at the freezing point. Assuming whatever value it shows at the freezing point follows a normal distribution, which the mean is at 0, but standard deviation is 1 degree Celsius. Find the probability that for a thermometer the temperature at freezing point shown is below 1.58 degrees Celsius. Right, so some keyword we see here. Right? So what keyword is the value shown is a normal distribution. Right, so we have to given the normal distribution to solve these type of questions. Right, if it's not normal, then we cannot have any assumption, right, other than that. With the mean to be 0 and standard deviation to be 1, the unit is degrees Celsius, agree with the unit at the end, so we can ignore that. Right, so what we find is at freezing point, the shown value is below 1.58 degrees Celsius. So we can draw the density. What we know is the x is the random variable, is the temperature shown at the freezing point. Right, is our random variable for thermometer. This random variable follows the normal distribution have mean is 0 and variance is 1. Right, so what we need to find is this shaded region of the temperature shown is below 1.58 degrees Celsius. So what we need to find is the probability of the random variable to be less than 1.58. Right, and we mentioned that, well, not every normal distribution can be done, but only the standard normal distribution could be done, which means we need to convert the x into the z-score. So from that we need to convert into z-score. Which the x value for the random variable is 1.58. The mean is 0. And the standard deviation is 1. We still get the value of 1.58. So we have the standard normal density. We'll be finding for the area less than 1.58. Well, which this x is the original data, but this z is what we found from the standardized step. Right? In this case, it's just lucky that we get 0 and 1 for mean and standard deviation. A lot of the case, it is not. And we have seen already, right, to find the z-score to be less than 1.58, we need to use the phi of 1.58, which means we need to go to the table. Right, so let me erase some information there. Right, that was the density of the original distribution. Then we convert the z-score. We get the result of 2 digits decimal of 1.58 still. Then the question becomes the z-score less than 1.58. Below, in other words, is less than the sign of the original question. Original, what we're seeking for, is same as after we convert into the z-score. Since the x is just taking place over there, then the less sign will be still the less sign. And for the z-score of 1.58, that is the table value of 1.58. So the last question is how we get the table value. Right, the z-score we find is positive. Right, it's a positive number, so on the two sides of z-score table we will go to the positive z-score side. But on the second page, which is the positive z-score side, that has different row and column. Right, the column which from 0.0, 0.1, and so on, the row on the top has basically 10 rows from 0.00 to 0.09, which the row over here shows the first two digits, which we containing the first digit before the decimal and the first decimal place, first two digits. And the column here shows actually the third digit or second place of the decimal point, which if we're looking for the 1.58, it is 1.5 and together with 0.08. 1.5 together with 0.08 will make the number 1.58. Right, so the column over here we can see is the value of 1.5, and the row over here we're looking for 0.08. Combined together is the value of 1.58, which this value inside is called the table value. Right, so we go to the row of 1.5, the column of 0.08, and the intersection is the probability of 1.58. 1.58. And even it's hard to see maybe, but that is the decimals, 0.9429. Right, so the intersection of 1.5 and 0.08 will be our answer, and the table value we get is the phi, which is the probability mass function, which in other words it is the probability of z-score 1.58 and less. And since asking for just phi of 1.58, we're just pulling out from the table, that is 0.942, right? So first two digits of z-score is the column, looking for it first, 1.5. Then the third digit or the second place of a decimal is the row over here, and the intersection is the probability, or in other words the table value of 1.58. the probability less than that. Let's see the next example. Alright, so this is our next example. Now we'll see, well, when designing a seat in a car, a height of people must be considered, that we need to consider the sitting height especially. And we know that men is usually have height higher than the women, so if we consider the case of men, then women will be mostly covered. I then consider which is considering the worst case scenario. The man's height is normally distributed with a mean of 36 inches and standard deviation of 1.4 inches. And a certain car is designed that could not accommodate a man taller than 38.8 inches. So which means the sitting height, if the sitting height is taller than 38.8 inches, that cannot be fitted in a car, or not that comfortably fitted. I find the probability of man not fitting in the car, which not fitting in the car means the man's sitting height is more than 38.8 inches. Alright, so first of all, what it tells us, the sitting height is normally distributed, mean of 36 inches, standard deviation of 1.4 inches. Right, so we know that the man's sitting height is normally distributed of mean 36 and standard deviation of 1.4. So variance will be 1.4 squared and standard deviation is 1.4 inches. And man not fitting the car is finding the probability that the man's height is taller than 38.8 inches. Right. Sitting height especially taller than 38.8 inches, that cannot be fitted in the car. So when they're asking not fitting in the car, they're asking for what is the probability that the man's sitting height is greater than 38.8 inches. For the random variable, it's normally distributed with mean of 36 and variance of 1.4, so 38.8. Is about here, and we're looking for is this tail. Then for the z-score, we use still the formula, take away the effect of the mean and get rid of the effect of the standard deviation, which turns into a standard normal distribution. X value is 38.8, the mean we find or given is 36 inches, and standard deviation is 1.4. So if we use calculator, again we see step-by-step work to find the difference first. Gets 2.8, and when we divide by 1.4, as I always ask you to keep digits into 2 decimal places, even though you find out it's a whole number, but always keep it as 2 digits of decimals. Right? 2 digits of decimal, because we have table using or table given is 2 digits of decimal places. Right? So that is what we need to find. Converting to the z-score, we're looking for the probability of z greater than 2.00. Which is 1 minus phi of 2.00 is the 1 minus the table value, and the density for z. We also need to draw that. Have 0 in the middle, we don't need to show that. If you want to, could. And the cutting value is the 2. And we're looking for more than 2. So the shape of the x random variable and the z-score are agree to each other. You will not get something like for the right, and we're converting z will go left. Always agree with the original what was asking. Then we go to the positive side. Since the z is positive, we have 2.00, so we go to the value of 2.0, and second digit is also 0. We get a probability of 0.9772. It's a decimal, 0.9772. And when we subtract that value by 1, from 1 we get 0.0228, which the car is being designed nicely. We can get that conclusion. Only 2% of men cannot fit it in the car, or be shorter amounts of women cannot be fitted in the car also, because women usually will have shorter sitting height. The mean and standard deviation will be shorter, but of course extreme case also always occur. Right? We have about 2.3% of men cannot be fitted, but you can always bend in that car, right? Maybe not sitting that comfortably, but still able to fit in the car. Alright, let's see the next one. Right, so the next question we can see here, right, the SAT score given is normally distributed with a mean of 998 and standard deviation of 202. Some school called BMCC requires SAT scores minimum of 700, which means if your score is more than 700, you're able to accepted by the school. I find the percentage of students satisfy the requirement, which means satisfy the requirement means equivalently has the minimum of 700. Minimum of 700 means 700 or more.